Welcome to Microsoft Build 2017. Have you ever thought about using richer typography in your app or your website, but held back from that because you were concerned about the number of additional font assets that might take and the impact that would have? Are you concerned about your app package size and disk footprint, or your page download times and the impact that additional fonts might have on that?
If these are concerns you have had today, we are going to talk about an exciting new technology that not only addresses some of these concerns, but also enables even richer typography than was possible before. Hi, I'm Srinath Shanbag. I'm a software engineer with the Windows Graphics team.
And I'm Peter Constable. I'm a program manager in the Windows Graphics team. The technology that Srinath and I will tell you about today is OpenType variable fonts. But before we get into that, I want to take a few minutes to review some things with regard to typography. Text is super important. Text is part of almost every user interface. It makes up much of the content in our apps or on our websites. Some people may take it for granted, but you know that design matters. If your content doesn't look good, that can turn people off, and that's a bad thing. Because text is such an important part of our content, it really deserves our attention. Good typography communicates with clarity, purpose, and power. I want to take a minute to review some concepts with regard to fonts. This may be familiar to many of you, but perhaps not to others, and it's important, so I want to touch on this. Font designers, when they create fonts, will often create a group of related fonts with similar designs, what we refer to as a font family. And within that family, they'll have different styles that are variations of the design. Typically, they may have multiple variations on some design variation parameter, which we refer to as an axis. For example, a font may include a weight axis with variations for light, regular, and bold that change the darkness of the text. Or a font may include design variations on two different axes, such as weight and width. So in addition to regular versus bold, you can also have regular versus condensed. And we refer to these as axes because we think of these as orthogonal, working independently, and so combinable. And so therefore you can have the combination of bold and condensed. A font can differ on any number of axes. For instance, in this example, the font designer has chosen serif versus sans serif as an axis of variation in their font family. It's entirely up to the particular font designer what axis of variation they want to use in their family. So these are concepts that will be important as we go forward. All of these different variants within a font family are separate fonts. And so if you want to use multiple design variants in your app or on your site, you're dealing with multiple fonts. Let's take this example, which is something that you may have had to deal with in the past. Suppose you've got some content that's going to be presented in different contexts, perhaps on a desktop that's got a wide aspect ratio, but also on a mobile device such as a phone that has very narrow columns. Here we've got the same text set with the same font in both of those layouts. When the same font is used in the narrow layout, you end up with many fewer words on the line, and that can interrupt the flow of reading for the reader. There's also many different hyphenation points, which can be a distraction. And you'll notice that the heading is spilling over onto 3 different lines, which doesn't look as good. Now, if you've had this kind of situation, you may have dealt with it with some responsive design techniques where you recognize that you're in a narrow column and change the layout, but also change the typography. In this case, switching from a regular font, regular and bold font, to condensed equivalents from the same family. So with the condensed font, the text doesn't take as much horizontal space. You get more words on the line, fewer hyphenation points, and you balance the headings better. So one example of things that you may have done using multiple fonts from the same family to deal with a typographic challenge. But notice that we've doubled the number of fonts that are being used. Take this example, which has a layout of some content, kind of like a newspaper article. So Srinath, a question for you. If you ignore the company heading at the top of the line, focus on the article. How many different fonts do you think are being used there?
Well, I see the regular and the bold version in different sizes.
So we know that OpenType fonts are scalable. One font can be used at different sizes. So we're not too concerned about the change in size because that doesn't add to the number of fonts, but the different designs do involve new fonts. So we're interested in how many different designs are being used here. We've got a regular weight of the family that's being used for the body text. But then in addition, we've actually got 3 different bold designs. These are separate designs of the bold designed to work for different elements. You may notice this in particular for the title at the top that's set at a much larger size. The letters are more condensed. That's to allow the large text at that large size to fit better on the line and to provide a better balance of overall color on the page. So multiple fonts from within one family working together to create good typography. Now that's an example of some content that is text-centric. Let's look at a different example that doesn't use as much text, more like an application UI. That's this example from the Store app that we have in Windows. And here, you don't have as much text, but you've got these different UI elements, and there are different members of the Segoe UI family that are being used together in a complementary fashion to create clarity and good information hierarchy. So we're using regular, bold, semi-light, and light for different elements to create an information hierarchy. If you're familiar with the design guidance that we give on the MSDN site, and in particular, the guidance around typography, you'll see recommendations on using different fonts for different kinds of text elements at different sizes that create a good information hierarchy. And we actually recommend use of 5 different members of the Segoe UI family. Now, if this were in your app and you were using custom fonts, if you want to follow similar guidelines for good typography, you'd be using 5 times as many custom fonts, or perhaps even more, to come up with your good typography. So that has an impact on your app package size, or on a website, on your page download times. These are challenges that we also face in Windows itself. In Windows, in the Segoe UI family, we actually ship 12 different fonts, different variants of Segoe UI. But we use other font families for other languages. So let's take Chinese for an example. For Chinese fonts are generally very big because Chinese uses tens of thousands of characters. Because the fonts are so big, we can't afford to put 12 different variants from this font family into Windows. It would take up too much disk footprint. And so we make these compromises in the typography for Chinese. Now, even for English, with Segoe UI, our designers would like to be using even more variants of Segoe UI, but we can't give them those yet because of the footprint implications. So we have this challenge with rich typography that to get rich typography, you want to use many fonts from a family, but then you deal with challenges around footprint, around download times, and just the sheer number of assets that you're having to manage. OpenType variable fonts is a technology that can help with these problems. This is a technology that we announced last fall with the release of version 1.8 of the OpenType spec. And this wasn't something that we did, Microsoft, on our own. We led an initiative across industry, engaging with partners including Adobe, Apple, Google, and other companies to develop this technology. And so this is something that you'll be seeing not only in Windows, but in all major platforms. It's something that is still a work in progress, so we're working on platform implementation just like other companies are working on their implementations. The font tool vendors are starting to add support in their font tools, and so font vendors are just starting to experiment with creating fonts that use this technology. So it's still new, but things are happening fast. For instance, on the web, there's already draft extensions to CSS to support variable fonts. There's a lot of excitement about this technology. I just recently came back from a type design conference in Berlin, and this was the hot topic at the conference. Almost every presentation at the conference dealt with OpenType variable fonts in some respect. So very exciting, and you'll be seeing it all over. So what is an OpenType variable font? The best way to characterize it succinctly is to say it's a single font that behaves like an entire family of fonts. And that's because that one font has got information that the designer puts in to describe different design variations. And they can do that on a particular axis, in this example, using weight as an axis going from very light to very dark. But they could also do it on multiple axes, in this example, using weight and width. Or they could put in 3, 4, or perhaps even more different axes of variation within that one font. So the font designer selects a set of axes of variation, and in that way defines a design variation space for the font. Within that space, the font is able to access any part of that space, but the font designer can choose to assign names. And so we have this concept of named instances. That's an important part of the format. So out of this space of weight and width variation, they may pick this instance and call it regular, and another instance and call it bold, another to call condensed light, and another extended black. This is comparable to the situation where the font designer was creating separate, discrete, non-variable fonts and coming up with different names. But now you've got these all in one variable font. The font is able to access the entire variation space, but they're picking out these particular names. The named instances are going to be important when we talk about functionality in the Windows 10 Creators Update in a moment. But before we get to that, Srinath, why don't you show some of this in action?
Sure. So why don't we switch the machines to the demo machine? Okay. So the first demo that I have is a simple web page. In fact, I have created 2 identical looking web pages. They have 5 different font variants from a single family. The only difference between the 2 is the one on the right uses discrete fonts, whereas the one on the left uses a single variable font.
So 5 design variants coming from a single font. Is there some kind of graphics effects that we're applying, stretching the glyphs or something to achieve those different designs?
Well, in both cases, the font designers have specified the exact glyph outline that they would want to be rendered, and dwrite just does that. And like there is no special graphics transformation being applied.
So the font designer has specified those designs inside the font for all of those different designs. Does that mean that that one font is like 5 times as big?
Why don't we take a look? So let me just go to the directory where I have these web pages, and let me show you what the font file sizes are.
Mm-hmm.
So I have the discrete web page in this discrete directory. Let me enumerate the 2 type font files here. Okay. And let me do the same for the variable instance. Okay. Now you can see here that the discrete version of the page uses 5 font files, and they add up to about 692 kilobytes in all, right? Now the variable version of the page uses exactly 1 variable font, and that adds up to about 165 kilobytes.
So wait a minute. In the one case, 5 discrete fonts, 692 kilobytes, but the one variable font that has all of those same designs is only 165 kilobytes.
That is right.
So we're using some kind of very efficient representation.
Well, yes.
So why don't you explain a bit about how that actually is done?
Sure. So we know that OpenType fonts are outline fonts, and font designers specify these outlines as sequences of line segments and Bezier segments, and they specify the endpoints for the line segments and the endpoints and control points for the Bezier segments. So when creating a variable font, in addition to doing that, for each of those control points, they specify deltas that allow us to manipulate the default outline over the entire variation space. So in this example, you're seeing a queue here, and you can see the default outline and the control points on that, the outline points on that. Now, if the designer wanted to vary that outline and get to these inner, the blue one, the one which you see with the blue dot, now he would end up specifying deltas to move those control points on the default outlines to the inner blue version.
So the original control points for the original outline, deltas that shift those control points, and in that way derive another outline for a different design variant.
Yes, that is correct.
So can you show us this in some running code?
Yes, sure. So let me just bring up a simple test program that we have created. What you're seeing here is a simple test program. We have loaded a test variable font that we have, and you can see now, what you see now is the default outline for the Q glyph, and you can see the on-point curves, right? Now, the font designer has created a single axis of variation for this particular font. It's the weight axis. It goes from the light end of the spectrum to the bold end of the spectrum. He's also defined named instances in the font, and he's provided deltas so that we can go to any of those named instances. Okay, let me show you. So these are the named instances which the font designer has defined in the font. So you have an instance called light, semi-light, regular, semi-bold, and bold. And these named instances, before, if it were not a variable font, he would have created discrete fonts for each one of these, right? Now, he's provided these named instances, and he's provided this variation space and these deltas. And with that, we can do more than get at those named instances. We can get to any variation along the variation space. Okay. Why don't I show that quickly? So we are back onto the default outline. Okay. Now, let me show you what happens as I vary my instance coordinate along the variation space. So I'm going to tweak the instance coordinates, and you see that the outline sort of interpolates smoothly along the variation space. And at every point along the variation space, the design is actually exactly what the font designer intended it to be.
So the font designer has given these deltas, understanding that those deltas will get scaled to different amounts, creating these different intermediate instances of the font.
That is correct. But mind you, it's not a simple interpolation. It can get a little bit complicated.
But that's the basic idea?
Yeah, but that's the basic idea.
Yeah. So that's very cool. It's helpful to get a basic understanding of how the technology works. But why don't we also look at the functionality that we have in the Windows 10 Creators Update. We recently released the Creators Update, and many of our viewers are probably starting to use it. So why don't you tell us about the functionality for variable fonts that we have in the Creators Update?
Well, we have updated the existing dwrite APIs to recognize named instances. So what that means is that the named instances in a variable font are accessible transparently to the apps. So if you have some code which you wrote using dwrite or any of the frameworks that uses dwrite internally like XAML, and you run your old app on your existing app on the Windows 10 Creators Update, and you have a variable font installed, then your app is going to be able to access the named instances defined within that variable font just as is.
So no changes to the app. We can use variable fonts now.
Yes, we can.
Want to show us?
Yes. Let me show you two small demos. The first one, the first demo that I'm going to show, actually I want to emphasize the fact that nothing in your code needs to change. So for this purpose, I'm going to show a sample that we have already posted on GitHub, and it was not created specifically for this variable fonts. It's a sample which allows you to create a font set builder and then enumerate instances of fonts that font set builder contains. For the purposes of this demo, I'm going to point that sample to this fonts directory, which has exactly one variable font. Okay. Now this font has a few named instances. So let's see if that existing sample can find them. Okay. Oh, I'm running the creators update.
Right.
So,
of course, everybody's running the creators update by now, right?
sure.
Yeah. We certainly hope so.
Okay. So here, as you can see, that existing sample could see the 5 named instances which are defined in that variable font.
So no change to the sample, just pointed it at the variable font. DWrite was able to see them.
Yep. And if you want to look at the code, and for those of you who are used to writing directly using DWrite API, this may seem a little bit familiar. So what it does, it just creates a font set builder, enumerates the font files, adds them to the font set builder, and then it creates a font set using that font set builder. So when it creates the font set, DWrite enumerates all the font files that were added to the font set builder, and if any of those were variable fonts and they had named instances defined, then DWrite exposes those just as it would expose discrete fonts in the past.
So loads up all those named instances, and everything else looks just like it used to in the past.
Yes.
Cool.
Okay. So now we said that any application or framework that use DWrite internally gets this functionality just by running on the Windows 10 creators update. And XAML is no different. XAML uses DWrite internally. So if you build your apps using XAML, then you should be able to access the named instances from XAML. Why don't we take a look at a small sample of that?
Cool, because I know I can hear the XAML developers out there saying, show me.
Okay. So let me quickly switch over to the XAML sample. Now, as you can see, we have a simple page here. There is a text block defined, and I've set the font size to 60. Let me just add a few more font parameters like font family. And this is standard XAML stuff. Most of us must be familiar with this, or at least most of the XAML developers will be familiar with this. So here you go. Let's choose, say, Courier New. The XAML designer updates that. Nothing new there. We can set other properties like font weight. XAML has these options which it just throws out, but these will only work if a corresponding instance of a discrete font is installed there. So for instance, we know that Courier has Courier Bold. So if I say set font weight to Courier Bold, XAML can see that because we have Courier Bold in the system. But if I try to set it to extra bold, there is no such font as extra bold on the system, so nothing will change. Similarly, so let me get that back to bold. And similarly, if I try to set some other property like font stretch, for instance, and these are the standard options which XAML presents. I'm going to select, say, condensed. Now we know that Courier does not have a condensed variant on the system, so nothing changes. But we do know that Arial has a narrow variant which XAML exposes using the font stretch property condensed. And if I were to change this font family here to Arial, XAML will allow me to access that variant. Now, of course, I can also set this back to normal and get the normal version of Arial, and I can set this back to normal, and then I would be able to access the normal variant of Arial, right? Now, this is all using discrete fonts, right? Now, since the named instances are exposed exactly in the same way, we expect that if I point XAML to a font file, a font resource, which is a variable font and which contains named instances, then everything should work exactly the same, right? So let's do that. I'm just going to make a copy of this text block. I'm going to just make this variable here. I'm going to change the font family. Now, I don't have this font quite installed on the system, but I have added it to my resources, application resources. So I'm going to use the XAML MS Apex URI scheme
So this is what any XAML developer would do if they wanted to include custom fonts in their package, put it in the package, and then use the MS Apex URI to reference that font file.
Yes, exactly. So all standard, nothing has changed.
Mm-hmm.
I'm just making it point to a variable font file, which in this case happens to be Avenir Next variable.ttf, and it contains the font family Avenir Next variable. And you can see that the XAML designer is already accessing the default outline instance, right? So let's try selecting a few variants. Now, this particular font has named instances defined along both the weight and the stretch axis. So on the weight axis, you have normal, bold, extra bold. On the stretch axis, you have named instances for normal and condensed. Now let's try accessing them from XAML. Now I do exactly the same things that I did before for discrete fonts. I'm going to set the font weight to bold, and there you have the XAML designer update the design surface with the bold instance. Now I could set extra bold. Now since the named instance for extra bold is defined, XAML can access it.
Mm-hmm.
Now instead of normal, I can change the font stretch to say condensed, and there XAML can access that. So now we have variations along two axes, and I can obviously access the condensed bold version and also the condensed normal version, just like that.
So no changes in the XAML framework. We're just using text block elements just like we would have done in the past. So if my app already contains a text block, all I need to do to access the named instances of the variable font is just refer to the named instances of the variable font.
Yes.
That's very cool. And you didn't change the URI. So in all of those cases, it was pointing to exactly the same font,
Yes.
getting all of those named instances out of one font. So that's very cool. So that's functionality that we've got in the Windows 10 Creators Update. We'll switch back to the slides now and go forward to talk about things that are coming next. So we've shipped the Creators Update, and now we're starting to work on the next feature update for Windows 10 that will be released later this year in 2017. And for that, we're adding new direct write APIs that will allow you to access not only the named instances, but any of the design variations within the variation space of a variable font. So not only the named instances, but that continuous range of variation that the font supports. And that's going to enable some exciting new capability. Let's review some of the benefits of a variable font. We've seen that one variable font can provide more design variants in a smaller package, a smaller size. So that's a benefit on its own, but we also, through the new APIs that we'll be providing in the next update, will create opportunities for even richer typography than we've been able to do before. And I'll give one example of that. Come back to this example where you were using some responsive design techniques to detect when you've got a narrow column and switch to a condensed font. But if you look at the text, you'll notice that that condensed font is really very condensed. The text is really squeezed together, and that can actually interfere with the flow of reading. And in addition, the look is distinctly different from what you saw with the wider columns. It almost looks like a separate font. For the reader, they may detect that as being different. What if we didn't have to go to such a more condensed version? What if we could pick a slightly condensed version of the font? That's the kind of thing that variable fonts will make possible. And so in this example, we've picked just a slightly condensed variation from that variable font. And now we're able to still fit more words on the line, help the flow of reading, get fewer hyphenation points, but it's not changed so much, it's not squeezed so tightly to interfere with the flow of reading, and it still looks like the same design that we had with the wider columns. Also notice what's going on with the headings. Back in the original, even on the desktop, we had this wide column, but the bold font did not fit on a single line of text. It wrapped around and it created this ragged heading. What if we could squeeze that just enough to make that heading fit on a single line. And that's something that a variable font can enable us. And so that's what we do in this case to end up with the heading on one fit to one line to give a much more professional look to the typography. So that's just an example, a couple of examples of the things that we'll be able to do with variable fonts, accessing the entire range of variation defined in the design variation space of the font. So that's stuff in the Windows 10 Creators Update and stuff that's coming in our next update. So what can people do now? You can get the Windows 10 Creators Update and you can start trying things out. We mentioned there's not a lot of fonts out there yet, and we haven't added any variable fonts into Windows itself yet. But the fonts that we've used in our demonstrations here, these are both available on GitHub. You can get those. If you search, you can probably find some other demonstration variable fonts that font vendors are starting to produce. So give that a try in the Creators Update. And then for what's coming next, if you are picking up the SDK previews, then look in a month or perhaps 2 months, we'll have our new APIs added into the headers of the SDK update. You'll be able to get those, try those out in your app, and pick up the Windows Insider preview builds. Once we have our direct write updates, those will be available in the builds. You can try that out. And if you're interested in knowing more about the font technology itself, then we've got one more link in the deck here to a chapter from the OpenType spec that gives an overview of the font technology and more explanation of exactly how it's working. So that's what we have for you today. We hope you're excited. We're certainly excited about this. And as mentioned, there's a lot of excitement among designers there. We think that OpenType variable fonts will hold a lot of good value for you and your apps.
Thank you for listening, and see you next time.
See you.